In question 2, we're asked to solve four different equations, and these do focus on some of the things that we've been working on in Chapter 4 and Chapter 3. The first question, question number, or part A of question 2, is an excellent opportunity to practice the technique that we're calling fraction busters. As I look across my denominators, I see a factor of 7. I see Try that again. I see a factor of 2, a factor of 7, and 14. Well, it turns out 2 times 7 is 14. So if I push through factors of 2 times 7 throughout the entire problem, right, it will clear all of my fractions. And that's going to be my strategy here. So, so every single one of these numerators is going to get brand new factors of 2 times 7, right? And I'm going to put a purple dot here just to indicate that for each one of these, and I got to be careful, this numerator is a binomial, so both of those need to get any factors that I distribute across this fraction. So each one of those things that I've just put a purple dot by are going to get new factors of 2 and 7. And visually, when I look at this first part, right, when I put the 2 times 7 in that numerator, in that first numerator, I can see that the 2 that I'm multiplying by and the 2 that lives in the denominator are going to cancel. They're a common factor and they're gone. And this is going to leave me with just a new factor of 7. So I have 5x times 7, which is 35x. Again, why is it just 35x? Well, if I wanted to, I could write it as 70x, but then I have this 2 in the denominator and it would cancel. It's the same thing. I'm just choosing not to do that arithmetic and just go ahead and cancel out the common factor first. Let's move on to the next term. This second term right here, right, we're going to multiply this entire fraction. I'm going to place right here at the purple dot. We're going to place our 2 times 7. And when our 2 times 7 go there, you can see that the 7 in the denominator and the 7 in the numerator form a giant one, and they're gone. And this is going to leave me with just 2 times 3x, which is 6 times x. Okay, so that 3x over 7 is going to become just 6x. The next part, you can see I've got 2, and I'm going to multiply that by 2 times 7. 2 times 7 is 28. And then finally, on the right-hand side, when I multiply that by the 2 times 7, remember that is the number 14. That 14 and the 2 times 7 that I'm putting in that numerator are going to also form a giant 1. So this part literally just becomes what the numerator is, right? This is just going to become 11x plus the number 4. Nothing to distribute across there because both the 2 and the 7 were eliminated with the 14. At this point, I just want to appreciate the fact that this looks much better than the original equation. In fact, let me get rid of all of the stuff that we've done there. That transformation alone was well worth thinking about fraction busters and eliminating the fractions. Over on the left-hand side, this is going to become 35 and 6 is going to make a 41x plus 28. That's going to equal 11x plus 4. If I take away 11x from both sides, that's going to give me 30x plus 28 will equal the number 4. And if we subtract 28 from each side, that's going to give me that 30x is equal to negative 24. And then finally, the final step here, I'm going to divide both sides of this by 30. Divide the left-hand side by 30, I get x. Divide the right-hand side by x, I get negative 24 over 30. And no one's penalized for that answer. That's a fine answer. I'd be so happy, so pleased if I saw that. It is reducible, right? Both the 24 and the 30 can be divided by 2, for example. So I could get negative 12 over 15. And then I might recognize, oh, that has a common factor of 3. If I divide the numerator by 3, it's going to give me, negative 4. And divide the denominator by 3, and it's going to give me a 5. So probably 4/5 is where I would leave that. I think that's also equivalent to what is it, negative 8/10, negative 0.8. But there we are. That's question number 1. The value of x that makes that true is negative 4/5. Next problem. Again, it's this idea of looking inside. It is an exponential equation. The tool that we have for solving exponentials at this point is to rewrite it so that the bases are the same. I see in my bases, right, here are my bases. One of my bases is 1/25th, and the other base is the number 5. And when I see those two values, I immediately think, okay, I'm going to go to a base of 5. So I can just rewrite the left-hand side. This is going to be 5 raised to the 3x minus 4 power. And on the other side, I see 1 over 25. If I'm not real comfortable with what the heck that is, I might look at some different powers of 5 and play with them for a while. When I get into the negative exponents, I quickly see, oh, wait a minute, this is a 5, this is 25. 25 divided by 5 is 5, 5 divided by 5 is 1, 1 divided by 5 is 1/5. Divide by another 5, it's 1 over 5 squared, or 1/25. So this is how I'm going to rewrite the 1/25. 1/25 is 5 to the negative second power. And then I'm going to raise that to the x minus 5 power. Okay, so I have this power to a power, right? You can see I have 5 raised to the negative second, and I'm going to raise that to the x minus 5 power. So I got to remember that I am multiplying there, and I have to hit both of those terms, the x and the negative 5, with that 2. So I might write this one more time. 5 to the 3x minus 5 equals 5 to the negative 2x plus 10 power. There we go. Negative 2x plus 10. Fabulous. Fabulous. At this point, because my bases are both identical, right, they're both the number 5, our strategy is to set this exponent equal to this exponent. The only way that these can truly be equal is if this exponent, 3x minus 5, is exactly the same as this exponent, negative 2x plus 10. If I add 2x to both sides, we get that 5x minus 5 is 10. If I add 5 to each side, we get that 5x is 15. And then the division property of equality, x would be the number 3. So x is 3 is our solution for part B. X is the number 3. Jumping to 3. On 3, we have a equation that has a chunk of it that involves the square root of an expression. The expression is 3x minus 3. We're going to go ahead and isolate this entire chunk of the equation, right? I want to get this part, the square root part, alone, right? My strategy is to just get this part by itself. So in the entire thing, right? So when I look at this, there's a couple of operations that I want to undo. If I want to get this expression, the square root of 3x minus 3 alone, the first thing I might do to both sides is divide by 5. So this is going to become 4 times the square root of 3x minus 3 is equal to, let's see, I'm subtracting 5 from both sides. When I subtract this side 5 from the right-hand side, I end up getting the number 24. And then the next thing that I might do is, again, my goal is to get the square root portion of this alone, to divide both sides by 4. So this is going to become the square root of 3x minus 3 is equal to 24 divided by 4. See, half of 24 is 12, half of that is 6. This is the number 6. All right, so now that I have that, I know that the only way that this thing can possibly be true is if the expression inside, right, if this thing inside was the number 6 squared, right? My thinking is, hey, I know that I've got this thing that I'm taking the square root of, and if this was 6 squared, right? If I squared 6 and then take the square root of that, I would get the number 6. Okay, so at this point, looking inside, I know that the expression inside the radical, this 3x minus 3 must equal 6 squared. It must equal 6 squared, because I'm going to take the square root of that. And when I take the square root of that, I'm going to get 6. So I just set this equal to 6 squared and then solve. If I add 3 to both sides, I get that 3x is equal to 39. And if I divide both sides by 3, I get x is the number 13. So for part C, x is 13. Last part of this question then is D. Here we go. The only thing that makes this slightly difficult is the fact that this expression, right, confuses us. It's like, why didn't, what is this, right? What is 1 over x to the negative 1, and why is it in my equation? Well, if we just think about rewriting this, think about it. This is 1 over x to the negative first. I can certainly multiply this chunk of the equation by x to the first over x to the first. In doing this rewrite, I'm not changing the value. It's the same thing. Notice now that the denominator, right, x to the negative first times x to the first is just the number 1. So I'm left with, this is just x, right? This is 1 times x to the first. So this entire thing is nothing more than x. Also, I can use the distributive property here. I'm multiplying 3 times this 2x and this negative 1. That's going to give me 6 times x minus 3, right? So I hit both of those with a factor of 3. And then I have this plus x and then plus 4, and that equals 15. If I rewrite the left-hand side can be simplified to 7x plus 1 equals 15. Subtract 1 from each side, 7x is 14. Divide each side by 7, x is the value 2. So 2 is the value that will make this equation indeed true. All right, that's it for question 2.